Hello, hello.
Hello,
Welcome all.
hello.
Yeah, great to have you all with us. We are now live doing this webinar with Lisa. Hi, Lisa.
Hi, nice to meet you this evening.
Yeah, great to have you with us. So Lisa and myself are from Big Data Boutique. If you're watching this, yeah, sorry about the glitch. So if you are watching this, you probably know who we are, but if you're not, then a quick one about us. We are Big Data Boutique. We are consulting firm, premium consulting experts about big data technologies. In general, we do everything around the big data, open source technologies. So, and that is to say, we do things like ClickHouse and Spark and Flink, and then a lot of OpenSearch as well. And we are partners with many of those technologies and the vendors and all, the people who actually build them. So we are a globally distributed team. We are globally recognized OpenSearch experts. And like I said, we also do other technologies as well. We do build a lot of big data technologies and also around Gen AI use cases. And that's what we are here to talk about today. We do a lot of OpenSearch, and as part of what we do around OpenSearch, we both build new use cases, so Gen AI, RAG, and again, a vector search, vector database, and we'll talk a lot about that today. And we also work a lot around the operations of OpenSearch, and we've seen a lot of clusters in the wild for various use cases on various sizes and shapes being used and misused. And we're very well trained on helping customers to operate them correctly. And as such, we've actually built a product we call this Pulse for OpenSearch, and it helps you get, make OpenSearch great again, if you will. We make sure that OpenSearch is operating at full capacity. It's operating at max performance and the lowest possible cost. And you should definitely check it out. And from here, I want to hand this over to Lisa, who will maybe explain a bit about herself and then explain what she's going to talk about today. Lisa, floor is yours.
Thank you very much, Itamar. Thanks for the warm introduction and welcome, everyone. So first of all, my name is Lisa. I'm a Gen AI team lead and consultant here at Big Data Boutique. Formerly, I worked for Unity, formerly Iron Source and Elastic. And today we're going to be taking a crash course about building RAG applications with OpenSearch. So before we get started, I'd like to kind of prepare the stage and talk a bit about what expects us today. It's going to be a journey. So first of all, we're going to talk about what are RAG applications. This term is being thrown around pretty often, but I want to explain what they are and how they fit into the realm of LLM applications. Then we're going to talk a bit of high-level overview of what RAG application architecture looks like. And we're going to do that by using a specific example. We have a use case that is going to we're going to use throughout this crash course to better understand what we're talking about. Then we'll go step by step and we really understand what are the nuances and intricacies of building a RAG application. And then hopefully we'll have the time at the end of this hour to talk about a bit about evaluation, which in my opinion is one of the most important and under-discussed topics when building with Gen AI and LLMs. So let's get started. One second. One sec. So we have a bit of a technical issue. One sec. I need to re-import the deck. It's always like that when you work with technology. One second.
I'm here for moral support. All good.
All good. All good. It's not a presentation if a technical issue does not happen. This is how it works. I'm throwing out the old one and bringing in the new one. Here we have it. It's on. Yes, it's the right one. Good. So the agenda did not change, just the slide deck to a newer version. So first of all, let's go back to the beginning of 2023, where ChatGPT came as a storm into all of our lives. And I want to remind you that this is not a new thing. LLMs were out there before. There were AI models, and they were pretty capable. The only thing that was new with the introduction of ChatGPT is our ability to interact with them first through a very good user interface, and then with an API. And this is when I'm talking about an LLM application, I'm not talking about training a model or fine-tuning a model, which is possible, but not related to this case. We're talking about using an LLM via an API and using its output to give a special, unique, or better experience to a user. So this is the domain of LLM applications as I'm seeing it. And here in our specific presentation, we're talking about textual interactions. We're not going to be venturing into multimodal interactions. We're just talking about text. And I want to talk a bit about different patterns of interactions that you can develop with LLMs. So the first one is very simple, and it's actually something that a lot of people don't even think about when they imagine AI or LLM applications. It's actually the workflow. A workflow is just a series of tasks, like you would run it with a Lambda or maybe with a step function, and you could add an LLM to one of the steps to get a better experience. For example, if you have, let's say, a report that you run nightly, you could run a job to aggregate sales and revenue, costs, etc. You could add an LLM step to your flow, to gain new insights. For example, you could in that workflow, you could scan through the reviews that were left on your website throughout the day, and you could rank them by sentiment. And you could pick the best ones or the worst one and follow them to relevant stakeholders to maybe be passed on to management or featured in a newsletter. So that's one architecture that you could build with. Then there's the chatbot, which is pretty obvious. This is what we got to know and love when we started working with OpenAI, with ChatGPT. And it's just an interface where you create a UI that lets you input messages, and you go back and forth with an LLM, asking it questions, and it returns answers. It kind of remembers what you were talking about. But here we're talking about just an LLM, maybe with a prompt. If you want to add additional information into an application, this doesn't have to be a chat. It can just be a workflow or any kind of class in your application. You can use RAG, which is retrieval. It's short for Retrieval-Augmented Generation. And this is the part where you take an app, represented here by consumer. You use a database that stores some kind of information. Doesn't have to be a vector database, can be any database. And you use the information from said database to enrich the context that you send to the LLM to receive answers, right? So you use data stored in a local database and an LLM. Then, just because this has been the hype for the past at least a year, agents are pretty much the same thing. They also use access to data, but they don't access the database directly. They abstract it or encapsulate it behind tools. Some of those tools can access databases. Others can do different things. They can access your file system, or they can interact with other APIs. So, and use all of that together with an LLM to provide an applicative experience. So this is our overview. And now we can get with a practical example, like I promised, to illustrate the next steps that we're going to take. So for a practical example, we are going to look at a hypothetical insurance company. In this case, the document is from an American insurance company that I found online, but this can be any insurance company. And this insurance company wants to offer a new experience to its users. It wants to let them talk to their insurance policies. I keep hearing it all the time. People want to talk to their data. And it's pretty obvious why they would want to do it. People have a lot of information in those policies. They are insuring for different incidents. They have payments. Maybe they're behind on their bills. They have coverages, different coverages for each policy. They might have beneficiaries. They might be out of date. They might want to change them. And obviously, if something, God forbid, happens, they might also want to find doctors in their network and other health providers. So there's a lot of things that people would want to do when interacting with the data that the insurance company holds. And it's obviously not easy to do for anyone who's ever ventured into an insurance provider's website. And if this company is able to provide this in a very easy chat interface, it is probably going to offer better service and also save some time for their customer support. So with that example in mind, let's talk a bit about how I would approach building such a project. So obviously, since the topic of this lecture is choosing RAG, I'm insinuating that RAG is what I'm going to choose for this application. And the reason why I choose RAG, let's talk a bit about what it can do and what it can't do. So LLMs on their own are amazing. We all know that. But as models, they've been trained on a set of data that was cut off at some point. They're trained on a fixed and frozen data set. And sorry. If you remember about a year or two ago, there was, if you asked ChatGPT a question, it would say like, hey, sorry, I don't know, this information is too recent. I was trained on information up to, let's say, 6 months ago. However, today, if you ask it a recent piece of information or advice, it's going to say, it's going to answer your question. And it's going to answer your question. The way it does it is because it also has access to the internet. So it will search for information online. It's probably going to be able to answer your question. However, you don't really know where this information is coming from. So let's say it answers, you're not sure which website it's from. You could look through the sources, but if you're building a RAG for an insurance company, you obviously want to know that it's not bringing random information from anywhere, maybe from your competitor's website. Then obviously there's the topic of proprietary data or internal data. Here, we're not only going to talk about the company, about our insurance company, we're also going to talk about the user's data. And obviously, the model has absolutely no experience with the user data because it's very, very private. So if you want to build an LLM-powered application that uses private internal data, then RAG is definitely a good choice for you. And then there's a topic about of numeric data. Numeric LLMs are not great at math. We know that. They're getting better. But you can definitely aggregate data using a different tool. Let's say in your workflow, you can aggregate numbers, and you can use an LLM, providing it that numbers, let's say, to write an email to management and presenting the information about the report, the last night's report, in a better way. Another thing to keep in mind when choosing RAG is domain knowledge. So in our case, it would be insurance. Insurance companies have a lot of acronyms and terminology that might not be used on the internet or in any data set that the model that you're working on was trained. So you might want to teach it or provide it with relevant acronyms, relevant terms, and making sure that that it's aware of what it's seeing. And before we move on, a word about context engineering. This is a term that I encountered. I think it was released in the paper about 2 months ago. I'm sure it was out there, but it really got popularized recently. And context engineering is just the concept of when you're working with an LLM, via an API, your ability to influence it to give you the results that you want is by providing it with excellent context, right? If you build it in a way that it's focused, that it's easy to understand, that it's clear, you're going to help the LLM perform the task that you want it to in the best way possible. So what we're doing here when we're choosing RAG, when we're building our application, everything that we're doing is focused around being able to provide the best context possible to the LLM to perform a task. So now, with that in mind, I'm going to walk you through the 3 stages of building an LLM application. And I've done these projects multiple times, and it's always the same process. It's always these 3 steps, and I'm going to ground them in the example that we're working with. So let's dive one level deeper. So first of all, we have document processing. So an insurance company, in our hypothetical example, and this can apply to anything that you're considering to build. This, this part is where we take the documents that exist in our organization, we process them to a manageable format. We'll definitely discuss more about that. Then we probably use something called an embedding model. We'll touch about that in a second. I have a whole separate lecture about that, but it's one of my favorite and magical pieces. And after we do that, we store it in a database in order to be retrieved later. We're talking about retrieval-augmented generation, so we need to store documents in a place where we can retrieve them. Now, this database doesn't necessarily have to be a vector database. For example, if we're building an application that just provides, let's say, numeric information based on some aggregations, retrieval can be done from a regular database. But very often we're dealing with a large amount of textual information. And for that, a search database like OpenSearch plus having vector abilities is going to help us build the search experience that we're looking for, and then the LLM application experience that we're going for. So this is the first part. We take documents, we do some magic with them, we embed them, and then we store them. Once we have our knowledge base in place, this is the point where we bring in our users. And in this part, we're going to let a user ask questions, right? The whole idea of our insurance company is to let people ask questions about their insurance policies. They're going to use free text and ask questions. We're going to take their questions and process them in such a way that we understand what they're looking for. And this is still the magical part. We're going to use the same embedding model. This is key. It has to be the same model to generate a vector. I promise we'll talk about it in a minute. And get the best documents, best matching documents from our database. Okay, in this case, OpenSearch. With hopefully our best documents at hand, after we fine-tune our system, we can then do the work of processing these results, aggregating the different pieces of information, and then finally preparing our prompt, putting all of those pieces in place together with probably a system prompt or a task prompt, sending it to an LLM, and returning the information back to the user. So this is a very, very high-level architecture of how an LLM application looks like. We have pre-processing, we have our second step of taking in the user question and retrieving documents, and then we put it all together and generate an answer, hopefully to answer the user's query. So that is our very, very top level architecture. At this point, our user of our insurance policy would get an answer to some of their questions. This is the point where I want to dive deeper. I really encourage you to ask questions in the chat, and Itamar will let me know if you have questions. Feel free. I am eager. We do have questions. Okay, Itamar, this is great. So please do ask questions. What kind of files do we use to provide domain knowledge to an LLM? Is it possible to use a PowerPoint? This is a great question, first of all. You can use pretty much any type of file to provide knowledge. This would come in, this is exactly what we're going to have on the next slide. In our pre-processing phase, like if you look at step 1, you have document processing. At this point, you would extract them from whatever file they're in. It can be a scanned PDF, like you would use OCR. You can use Excel, you can use Word, you can use PDF, you can obviously use a PowerPoint file. But what you would do is you would use some kind of library that is able to access that file and extract relevant media from it. In our case, it would be text, because that's what we're focusing on here. But you can also extract images, you can extract charts, you can extract any kind of information that's in there. So yes, you can use a PPT, but you would need to process it to extract the information from it. Anything else? Okay, I'll move on. If there are additional questions, feel free to ask them in the chat. So just like the question, the first thing that you actually do with any LLM application is exploring the data. And I cannot stress how important this stage is when you're trying to build an application. People often jump into the technical bits, trying different models and different databases and different embedding models. But actually, the most important part is just making sure that you understand what data you have, what you can do with it. So if we're looking at the very practical example of our insurance company, they obviously have a lot of different types of documents where you can find this information. So first of all, you would probably have some kind of general knowledge base. Maybe it's like, some Word documents that have like the policies of this company. You would probably have your user database, probably a relational database that has the profiles of users, their maybe their address, maybe their pre-existing conditions, etc. You will also have a bunch of signed PDFs that contain their actual policies. So you have to sign those policies. So usually companies have scanned versions of them. And this is what I have attached here, just a page from this policy. And those policies are complicated documents. They have a lot going on. And you will probably also have some information that's going to be relevant later in this crash course. You're probably going to have some kind of database or kind of repository of service providers. You're going to have doctors and nurses and physiotherapists that you can work with. And let's say this is the data available to us. So at the first stage, I will just explore this data set, and I'm going to try to understand how this meets the requirements of my agent. We already brought up a few requirements, right? We want to talk to the insurance policy. We want to know things about the beneficiaries. So I'm going to look for this information throughout these documents. And I'm going to create an inventory that lists everything that is available to me. Then I'm going to remove from it anything that is irrelevant. So for example, if every insurance policy has a cover page, this cover page maybe has some information about the company, maybe it has some phone numbers, maybe it has like some legal notes about the policy. Since we're not trying to make this data accessible using the agent, I'm going to remove it because, once again, our key here is creating good context. So anything that is irrelevant just shouldn't be there. You can't throw garbage into any database or any LLM and expect it to give good answers. So you're just going to remove everything that is irrelevant. Then we're going to look at hierarchy. Some documents don't have it. Some documents, let's say, are just news articles. It's just one title, some content, and that's it. But an insurance policy is definitely a structure that can't be looked at as just one large piece of text. As you can see from this table of contents, while itself it's not relevant to our agent, you can see that this document is structured in a very specific way. So if I'm looking, let's say, at one of the section D, if I'm talking about diabetes, I wouldn't know what the context of this title is unless I look at the title above it, which is section D, covered services, right? So diabetes is one of the covered services by this insurance policy. So I'm going to explore any hierarchies that exist within any documents. I'm going to note them and understand that they are there and keep track of them so I can process my documents better. I'm also going to look at private information. So some of the private information can be useful to my agent. For example, if my user lives in a specific place, it might be useful if they're looking for service providers. But if they're giving me their credit number or their bank account, this information is definitely irrelevant to what my agent does. And while I might not explicitly make it available, I don't want people trying to prompt engineer their way through the agent and extract private information. So if you don't need it for what the agent is supposed to do, just remove it. Just redact it before you ingest it. You don't want these problems afterwards. And in general, throughout data exploration phase, my main question, my leading question is, what is the question space of what I'm trying to answer? So like I said, we have the spec or like the initial requirements from our agent, but I'm going to really think about what I'm able to answer using this data. I might add some things to the requirements, but most importantly, I'm going to build an inventory of questions and hopefully answers that I'm later going to be able to use to test my agent, evaluate my agent, and mine for my agent to ensure good performance. So with that in mind, we've seen our data. Sorry. This is the part where we start pre-processing. This is the actual work. So we're in stage 1, we're pre-processing our data. And the first thing that we're going to do is to clean it up. We already said, we know in each type of document what's the relevant information. We can remove it. And then once we have it, it's still probably a very large blob of text, right? Like an insurance policy can be 50 pages long. Even if we remove the irrelevant parts, it's still 40 pages. So this is the part where chunking comes in. There are at least 20 different documented chunking strategies out there. You can cut things by just block size. You can cut by paragraphs or by pages, or try to find any heuristic that is unrelated to the content that you can come up with. But eventually, when you're working with important data that you have already explored, you will start gaining an understanding of what's a good chunk of text. The balance here is between providing not too much information, but not too little. A sentence might not be enough to understand the actual context of the document, but let's say a whole page can have multiple topics covered in it. So you're trying to strike a balance. And if you're not sure about what's the right balance, this is usually a point where I would consult with a specialist in the field to help me understand how to chunk my data. After understanding what's my chunking strategy, I might want to add some information. In our case, we will probably add the titles from the hierarchy that we have, but we can also retrieve additional information from other sources. Once we have all of the resources to prepare a chunk, we're going to shape it. And this is where something interesting happens. So we had our PDF, or like the question here asked before, our PowerPoint presentation, and we're going to extract the text from it with some additional context, and we're going to shape it in a way that is helpful to a model. And the nice thing with LLMs is that actually, if it's readable to you, then it's going to be kind of readable to an LLM. I'm not saying this is the only format possible. Someday it will take over all of us and start speaking in its own language. But for now, if you're just using plain English and good formatting, it really helps the agent understand what it's working with. So in this case, the previous page that you've just seen will turn into the hierarchy. And I'm using MD format. It's just a very readable format that people use to write documents. And LLMs are really good at understanding it. So here I'm using the title. Oh, you have more. I'll finish this slide and we can do it later. So in this case, we'll have the titles, like hierarchy, top level titles, second title, third title, and then we're going to have the text of each chunk. I'll talk about embedding and then we'll do the question. Once we have this chunk, so it's a reasonable chunk, we know exactly what it's talking about. It's talking about dependent eligibility to enroll into a specific insurance policy. We're going to use embedding. And embedding, like I said, it's a very magical thing. We can spend a whole hour talking just about that. But what you should know about it in this context is that it's a model. It's a separate model. It's not our generative model. It's a different model that takes in text and returns a vector. And this vector, it's very large, somewhere between 500 and maybe 3,000 numbers, has this magical ability to capture the meaning of the text. And what this means is, regardless of the fact whether, let's say, our text says person or human, dependent or child, or maybe if section A has a typo, it says contract holder without a space, regardless of the specific wording, it's going to capture the actual meaning of the text. And this will enable us to do really interesting retrieval patterns when we do retrieval. So this is a great time for a question before we move on. What is the embedding step in document retrieval? Well, thank you for that question. So embedding is the part where you take text and you use an embedding model as a specific model that was trained for that task. And what it's capable of is taking text and extracting meaning. It's a very abstract concept, but let's say apple is pretty similar to a banana, right? And a car is pretty similar to motorcycle. So in the space of that embedding model, those things would be close to each other, but far away as groups. So if I'm looking for something similar to, let's say, my daughter ate a banana, and so maybe a similar sense to that would be my friend ate an apple, or my friend chewed on an apple. So I would be able to find similar concepts regardless of the exact wording. And this is what I'm using here I'm preparing these documents to be searched not only based by keywords, but also by meaning. I hope this answers the question. Anything else? Do you change the source text for embedding? How? So yes, I took the original document, I extracted bits of the text, right? But I also added additional parts. In this case, I added the hierarchy of the document because I understood during my exploration that without this hierarchy being in each chunk, I can't really understand the text. It doesn't necessarily. So if I'm reading through a paragraph that talks about diabetes, like, I don't know, coverage and conditions, I'm not sure if this is like a section that excludes your eligibility or it defines your eligibility, or maybe it's about your partner's eligibility. So I need to shape the text. I take the raw text probably, but I also add additional information to make it clear to myself and to LLM. I hope this answers the question. What tools are used for data exploration? This is a great question. It's I don't think there's a one. It's not like there's the concept of, in data analysis, or like a data analyst would have EDA, like they would do initial data analysis that will try to like explore and get some statistics. But in this case, it's very textual data usually. And usually this is a process we do together with the customer. I think it's more of like a product manager / engineering manager's work to do this. You collaborate with the customer. You try to really understand how they see the data, how they work with the data, what's important, what's not important, what's understandable, what's not understandable. So it's the part where you really need field expertise. And it's really important. And I think this is why I'm highlighting it so much. I think it's really important to be prepared for this step. The rest of it is technical, but I wouldn't expect just an engineer, like someone who builds the application, to always be able to do that. Cool. So with our pre-processing done, it's time to ingest the documents. I hope that everyone can see, but it's a pretty straightforward piece of code, just Python code. I'm also assuming that most of the people here know what OpenSearch is, but just in a few words, it's a database. It's great for search. It can be searching through logs, but it can also be searching through large knowledge bases with a lot of text and vectors. So in order to finish the first step and to ingest data for later consumption, we're going to connect to an OpenSearch, create an index, which is not shown here. I'm just assuming it was already prepared for me. And then we have our chunks. So we have our documents that are processed, cleaned up, chunked up to pieces, embedded with vectors. And all of those fields, I'm going to index into the document. I'm using bulk API here, which is very easy. So if you have, let's say, 100,000 insurance policies, you would end up with, I don't know, like 1 million chunks from the documents. And together with all of their attributes, let's say like the account number of the user, you're going to index them into an index and make it accessible for search. And you would do the same thing, it's important to highlight, let's say with our health providers, right? We're going to have an index of health providers with all of their data, their phone number, their availability, and maybe some description about what they do. This is going to be important for the next step. So just to recap, we took our documents. I'm going to do a lot of these recaps until the end of the session. So we took our documents, we understood them, chunked them up, embedded them, and put them into OpenSearch for safe storage, where they rest now. And this is the point where we meet our user. Our hypothetical user is definitely doesn't care about what documents we have ingested in OpenSearch. He just has a problem, right? We gave him a chat interface, and I'm sure that everyone knows that when you have a chat interface, people like to complain. At least I do. So our user comes and says like, oh my gosh, sorry, I'm so sad, my knee hurts. Can I see a doctor? And this is a very innocent question, but behind it, a lot of magic needs to happen for us to be able to answer it well. So first of all, we'll need to clean it up. Cleaning it up means like if someone's being super polite, it's great for the AI overlords, but it doesn't really matter for the sake of our question. And the way we're going to do that is we're going to extract structured information from the user's question. So we want to translate the user's question, which is pretty straightforward, into something that we can work with. In order to do that, we need to understand a few things about their question. So what are they looking for? They're looking for a doctor, right? They're not looking for a nurse. They're not asking what to do. They're not asking about their payments. They're looking for a doctor. Then they gave us some specifics. So they're saying their knee hurts. So they're probably interested in maybe an orthopedic doctor or a surgeon. They're definitely not out there looking for a dermatologist for this specific problem. So we can extract this information. The way we extract this information is by using a smaller model. So query pre-processing usually, unless you can do it with NLP and unless the output is really still structured, you'll probably need a smaller model to process the request. Usually it would be a more lightweight model like, let's say, OpenAI's mini models or Anthropic's Haiku models. And you would use it to take the question and convert it into some kind of, let's say, a form or a JSON object that you can later use to query. Then we're going to use our querying logic, which we'll cover in a bit. And we're going to fetch doctors, right, for knee problems. But we also need to know where those doctors are, right? So we actually have the user's profile. We're still in the retrieval step. So we can retrieve the user's profile from our database and see, okay, this user lives in New York. He provided the address when he signed up. So we can use this address to offer him doctors. We'll also make sure that they're covered by his insurance policy. We'll also make sure that the copay is reasonable. We don't want him to pay full price for the doctor if he's talking to the insurance. And then we'll return him like with an answer. Here we're returning just one doctor. Maybe we'll give him a list. But then the user says, like, he can reply. This is a chat. So he says, but I moved to San Francisco. Now, this is not a question. This is just a follow-up on what he asked. Like, he's not asking about San Francisco. He's saying my knee hurts. Can I see a doctor in San Francisco, right? So we will need to actually consider the chat history, the recent history, or maybe not so recent history to understand more about what the user is trying to ask and rephrase the question. You can actually do this in the same step as extracting the information. You can provide it with some additional context, right? We said like good context, good results. So give it good context, which is actually the rest of the conversation. Let's say 5 messages or a summary of the messages, of the recent messages. And then it can actually adjust the form or the information extracted to answer the question again. So here we pre-process the query. And if we dive deeper and connect to OpenSearch here, I want to help you understand what's happening in the background. So historically, if we're talking about words like doctor or San Francisco, you don't really need AI or you don't need LLMs to answer the question. You just use keyword search. You can say like, okay, doctor is a keyword. I can do geospatial search around the location. I can sort by rating or price or whatever, and I'll be able to retrieve pretty relevant information. But the new thing with semantic search and this ability of using vectors to find documents is you're able to capture meaning, like I said. And the fact that the user is asking about their needs, any human understands what are the relevant doctors to this use case, right? They're not looking for, like we said, they're not looking for a dermatologist. So semantic search helps us understand that someone who has a problem with their knee is actually looking for an orthopedic doctor, right? This is the part where semantic search shines. But on its own, it's also not enough. Like if you just ask for anything that has anything to do with knees, you're ignoring very important information, like they're looking for a doctor. So combining them into what's called hybrid search is an approach that is often very, very helpful when building RAG applications, and just a fancy name for combining both keyword search and semantic search to get the right documents. Once again, since we're talking about OpenSearch, and my goal is to give you guidance and understanding that you can apply to your own use cases, I have some examples of exactly the same thing. So here we have a query. This is something you would send to the search API of OpenSearch. Here we have an endpoint that shows you how to do regular keyword search. So this query will just find a doctor within 10 kilometers of, I think this is San Francisco, from the latitude and longitude, but I'm not sure. You can catch me on that. Then we have a different type of query called a KNN query, which would only find things that are similar to what the user is asking. So it wouldn't filter for doctors, it wouldn't filter for location. It would just find anyone who treats knees. This can be a physiotherapist that is super experienced with knee problems, but it's not what the user is looking for. However, the combined query, which combines in a very natural way, is very, very helpful to the user. And this is the real power of retrieval with OpenSearch. It finds doctors. They must be doctors. They might be within 10 kilometers from where I am, but they should also be similar to what I'm looking for, what I'm asking about. So this will give us doctors that also treat knees and are close to me. And this would be good information to answer the user's question. Another good point for questions, if there are any, before we move to the third step. Thank you for presentation. Do you see embedding generation on near real-time ingested data feasible, or would you meant to do that in batches? I don't see any problem. It's not that like I don't see any problem. We've done that before. Embedding is a very, very fast algorithm. So you can also host it locally. Like you don't even have to call an API. You can host your own model if you have to. There are decent open source models, I think more than decent. Like there's E5, which is a great model. It's very lightweight. So I don't think the embedding itself would be the challenge. However, if your data changes very frequently, you would also need to consider its impact on the index construction. Under the hood, when you're changing embeddings, you're also constructing a data structure behind the scenes, which is pretty heavy. And there are options in OpenSearch to support that, but it just requires careful planning. So if you want to like update and like, let's say if someone's insurance policy changes, you can update it, like embed it once over, and it should be fine. So
I would just mention, we actually are about to also publish a blog on our blog that shows how to do that with Flink. So like Lisa mentioned, it's absolutely doable. We've done that before. And it's all a matter of, does it really worth it in terms of performance? And can your, I guess, ANN and HNSW algorithms work with that well? And you need to take that into account as well. So just wanted to chime on that.
Anything else? or we move on? Let's move on. Awesome. So once again, recap. We took our documents, we cut them down to pieces, we embedded them, we put them into OpenSearch for safe storage. Then our users came in, they had a question. We used the data in our indices to get the best information both by keywords and semantically. Now we have a lot of documents, could be user information, insurance policy information, doctor information, and we need to actually generate an answer for the user questions because he doesn't want to sift throughout all the documents that we just retrieved. So in this step, we just take the documents that we have and we think about how to represent them. And if you remember, I mentioned this at the beginning about 30 minutes ago, that luckily LLMs like to read the same readable formats that we do. So if we have, let's say, these doctors' information, we can just convert it to text. And I would definitely make sure to, by the way, just like LLMs generate a lot of emojis, I'm sure you've noticed, you can use emojis with them. I think that their rating, like the notion of a star, is a very good way to emphasize the meaning of this number. But I would prioritize it, but what's important for a user to know about a doctor, right? In the context of setting an appointment. So I would say like the doctor's name. I would definitely highlight their profession, like their specialty. And I would also add information, let's say, about their availability. Just in let's say I could tell the LLM that I want to set the appointment to the cheapest doctor or maybe to the nearest appointment. So I could also provide information that helps the LLM make decisions. And with all of that information formatted in a nice way, I could finally complete the third step, send all of that information. And once again, this information is information about the user, information about their policy. So I would like, okay, what is this user's coverage in case of an orthopedic problem, right? Or maybe they have a pre-existing condition. Maybe I would add some policies, like general policies from the company. And then with all of that information, it's going to be a pretty big prompt. I'm going to send it to an LLM, and it's going to generate an answer for me. And hopefully I will just send it to the user, and hopefully they'll be happy. But how will I know if they're happy, right? It all sounds nice and fun, but I think that pretty much anyone who's listening to this crash course understands that this sounds like fun and games, but in production, it's going to behave very, very differently. So I definitely want to, as we near the end of this session, to highlight the fact that it sounds nice, it will work in a demo, but as you're building it in production, you take many more things into account in order to make it good, in order to make it reliable, and in order not to embarrass your company and make your users angry. So first of all, let's touch on a few points. They're not all the points, but from my experience, from our experience, these are some of the most important points. So first of all, there's a topic of document processing. Document processing is hard. We're talking about a lot of documents that change, that go out of date. You need to make sure that you're building reliable pipelines. So if let's say if someone's insurance policy changed, you don't update that, the information is out of date, so it's not going to be good. And to make sure that you have good observability of what's failing, you have dashboards and you have retry mechanisms. Then there's the point of storage. Someone just asked about real-time updates. While it's possible, it does put some strain on OpenSearch or on any vector database. We're talking about a lot of documents with a lot of text, and the vectors themselves are very, very large. They can be from 500 numbers to 3,000 numbers in some cases. There are many strategies you can use. You can use quantization, which turns float numbers to integers. You can use new vector models, new embedding models like Cohere 4. Itamar, if you can paste the link to that blog post, I love it, which allow you to reduce the size of the embedding without losing almost any accuracy, which is really, really cool. Then there's the point of search optimization. Search optimization on its own, even without LLMs, it's not an easy topic. It's not like a trivial one glove fits all all cases scenario. So you just need to optimize the search. You need to understand how to optimize the search. And the way how you optimize the search is by having monitoring and evaluation. We'll touch on that in the last 5 minutes of this session. Then you need to remember that LLMs can fail. Sometimes they just don't return the response that you want. You can ask them to return a JSON, and sometimes they won't. Sometimes they will make up facts. So you need to start to feel comfortable with the probabilistic nature of their responses. So you need to write your system in a much more defensive way that can recover from failures, maybe by having retries, maybe by providing feedback, and definitely by providing a disclaimer. Never forget the simple thing about putting a disclaimer that this is an AI and you need to take everything with a bit of a grain of salt, even if it's really good and it passes all of your tests. And then also another point, results are not consistent. You can give the same prompt to an LLM and it will return slightly different results, or not so slightly. Just be aware of that. It's strange, like people are used to systems behaving in a deterministic way. Just if you have the same input, it's going to be the same output. And it's definitely not that way with LLMs. And this brings us to the topics of monitoring and evaluation, which are the last points of this crash course, which got pretty technical, but I hope it was helpful to anyone still listening. So when you're monitoring an LLM system, a lot of people just build a system. It's not limited to LLM applications. Everyone just likes to build the product, and then you're like, oh, I don't have any monitoring for this. Like, I don't know what's failing. If you're building an LLM system, please, please, please make sure to log at least these things. First of all, write anything that fails. A failure can be a document processing error. It can be a query processing error. So if a user asks a question and like you just don't know what to do with it, an error can be like the LLM is not available. Just log all the failures. This is good practice for any system, not related to LLM applications. Then latency and tokens. LLMs can get slow and they can get pricey. And if you release a RAG application, like you vibe code your way through an application with base 44, and you put your OpenAI token in there, your Bedrock token in there, you might be very sad after a few days because they can get expensive. Just log everything. Make sure that you set up your caps also, but mostly just log what model you used for what, how many tokens it took, both input and output, and then you can track what's happening in your system. And user votes. Like I said, answers might not always be what you want them to be. The best feedback you can have is the feedback that from your users. Make it easy for them to vote up or down. Don't encourage them to vote up. Encourage them through the UI to offer honest feedback. And then you might know what's being wrong. And then finishing with the most fun part. If you remember when we were talking about data exploration, we talked about building a set of questions that you can and want to answer based on the documents. Those questions are the key to understanding that your system works correctly, just like with TDD. If you remember the good old days of writing unit tests and integration tests for web applications or like normal software, these questions are actually the compass upon which you're going to understand that your system behaves well. You have a set of questions that should also contain good questions and bad questions. Maybe there are things you don't want to answer. Maybe you don't want to answer questions about your competition. These questions are going to be part of your evaluation. And evaluation is just the process of running your system every day through some kind of a sanity process and asking the same questions over and over again and understanding whether the answers are still good. Understanding whether they're still good is also, it's actually the hardest part. There are metrics, more than I can count, about how to evaluate whether answers are good. There are also approaches that try to use LLMs as judges to understand if, the original answer that you wanted is just as good as the one the LLM generated today. But eventually, this does require some manual overview as of today. Even state-of-the-art models can't always be right. And this is really something I implore you to consider. If you want to monitor an AI system, you need to keep track of it. Don't just set it out into the wild and let it roll. And another recommendation, this is the last one, and we'll move on to questions, is just to consider evaluating the retrieval and not only generation. Search is much easier to evaluate. We're actually working on an article about it, and we'll share it later. So follow our page on LinkedIn and our blog, and we'll share that very soon. And I think this is the point where we'll move to the summary, which is just, I'll just leave it to questions, and I hope I will get an opportunity to summarize everything we talked about. So Itamar, hit me with questions. We have like 5 minutes. Okay, is there any sample application walkthrough available which implements these steps? So I didn't prepare a repo for this stage. We do have Shraga available, so we can share the Shraga repo. So Shraga is an internal framework that we have, which we use to develop applications internally. We open source it. And I think that the Shraga repository, you can share it, Itamar, or just go to this article, lets you see an example. It doesn't have the data, though. But I'm sure we can provide it later. Another question? I just could not catch the beginning part. Curious about how you retrieve doctors on first step. So retrieval actually happens on the second step. First step was preparing the documents. So in our case, we talked about the fact that documents being information about the policies, information about the users, and information about doctors. Each of them would have different processing. You would have one pipeline to ingest and update insurance policies. Then you would have like information about the doctors. But I'm assuming that the insurance company already has its own database, or maybe databases of doctors that are available through different agreements. So this is how I would have doctors. It's not like I'm scraping them from the internet. Anything else? Where can we find tutorials about building it? Like I said, Itamar shared the Shraga repo. There are also a lot of examples out there, like Shraga is our framework. You can also use any other framework out there, like LangChain, LangGraph. They all have, and also all the vector databases have it. OpenSearch, Elasticsearch, Pinecone, they all have examples about how to build RAG. But these are the pointers that you need to remember if you're not building a tutorial, but you're actually trying to go to production. So keep track of, keep these points in mind. They will help you navigate the process. And I think that's our time. It was a pleasure to do this hour, and I'll hand it over back to Itamar.
Yeah, Lisa, thank you. It was great. Any other follow-up questions, feel free to reach out to us. I think, Lisa, you covered tons of materials, and maybe we can have a whole session for a full hour just for each and every one of those slides. We might actually do that. So if there is interest, definitely ping us, and we'll figure out, what would be the next topic for any other future webinar. Thank you, everyone, for joining us. Lisa, thank you for your time.
Pleasure.
And yeah, looking forward to meeting again on the next webinars.
Great to see you guys. Bye.
Bye-bye.